Hello and welcome back to another video where we look at topics in section 1 on the CSEC additional mathematics syllabus. In this lesson, we are going to spend some time examining the sum of a geometric series. We'll start off first by looking at a definition for a geometric series. Remember, a series results when we add the terms of a sequence. And so a geometric series is the indicated sum of the terms of a geometric sequence. So for example, here we have a geometric sequence, 3, 12, 48, etc. going up with r equals 4. And its indicated sum would be 3 plus 12 plus etc. going up to the number that is specified there. And in general, if we have a geometric sequence A1, A1R up to A1R to the n minus 1, once we start adding them together, we get our geometric series. Now, how do we sum the terms of a geometric series? What formula do we use? And so in doing that, we can create a formula. Now, the sum of the first n terms is indicating sum here, the sum of the first n terms of a geometric sequence, of a geometric series rather, AR squared up to AR to the n minus 1. Let's start with this. If we should multiply this series by R being the common ratio, then we end up with RSN is equal to AR plus AR squared plus AR cubed, etc. plus AR to the n in this case. And this is what we have here. And then if we subtract them, let's say RSN minus SN, then what we end up with is this. So notice that these terms will cancel out. And what we end up with is this term and this term remaining. So the first term and the last term remaining. And that will tell us that the first term of Sn and the last term of Rsn. So we end up with this. And once we do a factoring here, factoring out Sn, we end up with R minus 1 here. And factoring out A here, we end up with R to the n minus 1 on that side. And of course, dividing by R minus 1, we end up with a formula that we can use. And that formula is Sn, the sum of the first n terms, is equal to A, the first term, times R, the common ratio raised to the number of terms, minus 1, divided by the common ratio minus 1. So that's pretty much the formula. We can use the formula in another way, as in 1 minus r to the n over 1 minus r, depending on the value of r. So if the common ratio is greater than 1, then normally we tend to use a formula like this. But if the common ratio is less than 1, we can use it like this. But it's the same formula. Now let's try to use it on a question and see how it turns out. Here we have a series, geometric series, 4, 6, 9, etc., going up to 4 times 1.5 to the 10th power. So we know our first term, A is 4. We know our common ratio, R is equal to 1.5. And what we need is the number of terms. So what is the number of terms? Here we have the term containing 1.5 to the 10th. So the power is 10 here. So there are 10 terms plus this other term here. And that would give us 11 terms. It's important that we know the exact number of terms. So here, 1.5 to the 1, going up here would give us 10 terms, plus that 1 is 11 terms. So we can simply use the formula here. Sn is equal to A times R to the n minus 1 over R minus 1. And a simple substitution. And that gives us 4 times 1.5 raised to the 11th, since there are 11 terms, minus 1 over 1.5 minus 1. And of course, this gives us 4 times 1.5 to the 11th minus 1 over 0.5. Now, 0.5 into 4 here gives us 8. And that gives us 8 times 1.5 to the 11th minus 1. And if you haven't done that, if you haven't punched it in your calculator yet, then once you do that, the result is 683.98, which you can round off, of course, to 684. So the sum of the first 11 terms in this series would be 684. Let's try another question. Find the sum of 5 terms of a geometric series whose first term is 2 and whose fifth term is 62. So the first term is 2, so we know that A is equal to 2, and the fifth term would be A5, which would be equal to AR to the 5 minus 1. That's how we'd write it. A is equal to 162. Now what do we have? We have A, we have the number of terms, this is n, but we do not have r. And so we need to find r first. So we're going to find r. And this here can help us find it. So what we're going to do here is to substitute. So a is 2. So we have 2 times r to the 5 minus 1, which is 4, is equal to 162. So we want the other piece of our information so we can work it out. It tells us that no, r to the 4 is equal to 162 divided by 2. And 162 divided by 2 gives us 81. And now, since r to the 4 is equal to 81, what we want to do is find the fourth root of 81. Of course, that is 3. 3 to the 4 is 81. So the fourth root of 81 is 3. And now that we know our r, we can go ahead and find the sum using Sn is equal to A times r to the n minus 1 over r minus 1. So just plugging in our information there. A is 2, so we have 2 times 3 to the number of terms. The number of terms is 5, so 3 to the 5 minus 1 divided by r. R is 3, 3 minus 1. And what we get here is 2 times 3 to the 5 minus 1 over 2. Of course, that divides itself out. And what we end up with in the end is 3 to the 5, or 3 to the 5th power, minus 1, which is 243 minus 1. And our answer ends up being 242. So we can use the formula to do to find it directly. And in case that we're missing a value, we can use the general form of this series to find our missing values, and then apply the formula to find the sum of the first n terms. Now, some series are finite in that we can find the finite sum, or what we call a partial sum, because we're not adding all the terms. And in some cases, some series are infinite. So some series are finite and some are infinite. When it comes to infinite series, some of them are convergent and others are divergent. And we'll spend some more time looking at the convergence and the divergence in another video. But here we have two series, half plus a quarter plus 1/8 plus 1/16 plus 1 over 2 to the n. And if we try to add all of these terms together, then the question is, what number would we get, if we would get a number at all? And the question is yes. Now, what happens is, if you look at what happens to n here, this last term, 1 over 2 to the n, what happens to n as n gets really, really, really big? So we say sometimes as n tends to infinity, meaning it's getting really, really, really big. What happens to the value of this? What will happen is that as n gets really big, this number here will get really big. 2 to the, for example, 2 to the 10, 2 to the 20, 2 to the 100, 2 to the million. This will get close, this will get really big. And this number here will get smaller and smaller and smaller and smaller, going towards 0. And that would mean that this, the numbers here are decreasing and are moving towards a particular number. So in this case, this particular series will converge. Like I said, more on that in another video. While in this one, if you try to add all the terms in this one, 2 to the n, Notice that as you go up further, the numbers keep getting bigger and bigger and bigger and bigger. So if you try to add the numbers in this one, it's not approaching any number at all. Rather, it's just growing without bound. And so in this case, 2 to the n would diverge. It gets really, really big, while this one, this series 1 over 2 to the n converges because it's heading toward a particular number. 1 over 2 to the n is heading towards 0, so it's getting smaller and smaller and smaller. Now, a geometric series converges under a certain condition. So if the value of r, the value of the common ratio is less than 1, then what that means is this. That is, the value of the common ratio lies between -1 and +1. The modulus, the absolute value of, is less than 1. Then the sequence will converge. The series will converge. And if the series converges, then it has what we call an infinite sum, or sum to infinity. So in this case, this particular series will converge, and it will have what we call a sum to infinity, also known as a limit. And that limit is given as the sum to infinity. We often write it as this: sum to infinity is equal to a over 1 minus the common ratio. So this formula becomes important for series that converge. And when we find that sum, we call it the sum to infinity. Now let's use that. And before we use it to solve any problems, let's determine whether the sum exists for each of the geometric series. Now, the geometric series, as mentioned a while ago, they converge or diverge depending on the value of r. So if if the value of r is less than 1, that is, it lies between -1 and +1, then the series will converge. If it's greater than 1, then it will diverge. Now let's look at this. So if this is a series 3, 15, 75 plus 375 going on like that, then we can find r by saying r is equal to a to the an plus 1 over an by dividing two consecutive terms. And doing that, we can divide 15 divided by 3, and we realize that r is equal to 5. Of course, 5 is greater than 1. And so this particular series will diverge. That is, it will not have a sum to infinity because r is greater than 5. As this number r to the n goes to infinity, then 5 to the n is going to get really, really, really big. In this case, looking at the value of r, remember r is equal to a n plus 1 divided by a to the n, and so we can divide it as saying 4 divided by 8, which gives us a half, and a half, as you know, is less than 1. And because it is less than 1, this particular series B will converge. Now let's use this information some more. Let's say that we want to find the sum of the series 20, -16, -16 plus 12.8. As you notice, it's alternating plus minus plus minus. But what happens is that the numbers are getting smaller and smaller. So find the sum of the series, and notice here our formula. Now what we're missing from our formula is that we don't know what r is. We know what a is. A is 20, but we don't know what r is. But we can find r by saying r is equal to an plus 1 divided by an. And once we do that, we can say -16 divided by 20, and -16 divided by 20 dividing by 4 here, we get 4, and 5 is equal to -4 over 5. And so this is our r. It is less than 1. And so because it's less than 1, we know that the series will converge. And because it converges, it has a sum to infinity. So the sum to infinity of this particular series is going to be, first term, 20 divided by 1 minus -4 over 5. And here, it's going to turn out to be 20 divided by 1 plus 4 over 5, which is the same thing as 20 divided by, this is 0.8, 1.8. And punching that into your calculator is going to give 11 and 1 over 9 as the answer. Moving on to another question. Here we have find the sum to infinity from 1 to infinity of 1/3 raised to the n. Notice that our first term, if we put n equal 1 here, we're talking about the series from n equal 1 to infinity. The first term, inputting 1 here, is going to give us 1/3. The next term is going to be 1/3 square, which is 1 over 9. The next term is going to be 1/3 to the cube, which is 1 over 27, plus, and it goes on. Now, as we can see here, we have an A value. The A is 1/3, and R is also equal to 1/3. So we can put this information in this formula and find the sum to infinity. So that is, if you add all the terms, the sum to infinity is going to approach this number. The sum to infinity is going to be A, which is 1/3, divided by 1 minus 1/3. And this gives us 1/3 divided by 2/3, because 1 minus 1/3 is 2/3. And of course, a simple calculation here results in a half. So the sum to infinity of this particular series would be a half. Let's take another one. Here we have a GP. GP is the same, is general geometric progression, which is the same thing as a geometric series, depending on where you live. Some people call them progressions, some people call them series. Geometric progression has a common ratio of 0.65. Its sum to infinity is 120. What is the first term? So we're going to be using our formula here. So the sum to infinity is equal to A over 1 minus R. And what we know is that our common ratio is 1.65, but we don't know the A. So since we know the sum, then 120 is equal to A divided by 1 minus 0.65. And of course, A here divided by 1 minus 0.65 is 0.35, is going to give us 120. And a simple cross multiplication here tells us that A is equal to 120 times 0.35, and that gives us an answer of 42. So we can use this information to find R, or we could find A, depending on the information given. And that's how we go about finding the sum of a geometric progression or a geometric series, either by finding a partial sum, which is we find the sum of a number of the terms, or we find an infinite sum if it's a geometric sequence in which the terms converge to a particular number. So here we have gone through looking at the sum of a geometric series, partial sums, and infinite sums. That's it for now. As always, remember to practice to cement your skills. And of course, if you're new to the channel and you haven't subscribed as yet, then please do before you go. Thank you so much for watching, and continue to work hard.